Critical infrastructures such as airports, power plants, central banks and correctional facilities have a crucial importance in our society. This makes the assurance of their security an essential task. And it is a very difficult one. Video surveillance has been used to help to ensure security of such buildings, but has not always been effective. For instance, to cover all the important areas of a building's complex, a large number of cameras is needed. In fact, large critical infrastructure buildings may have thousands of surveillance cameras. In such environment, human visual inspection of all camera images is not effective. Automatic video detection systems can be a solution. In this case, images are processed by servers or embedded hardware to detect security-relevant situations. However, rule-based algorithms often used for this purpose have difficulties balancing the trade-off between high accuracy and reduced number of false alarms. For instance, image noise, illumination problems and cluttered background can cause false alarms. Occlusion or low contrast images may reduce the accuracy, making it difficult to detect real relevant situations. Artificial intelligence approaches as deep learning propose improvements for many of those difficulties. For instance, there are different convolutional neural network approaches for person or object detection. Here, we train a network with an annotated dataset to learn to detect people in images. The trained model can then be integrated into a server-based video surveillance system or run directly in an embedded platform. Although deep learning-based approaches have shown impressive capabilities in solving some specific computer vision problems, there are several challenges while building real-world applications, especially for embedded hardware platforms. At one side, the algorithms are complex and computationally expensive. On the other side, the proposed embedded hardware solutions often present highly heterogeneous and parallelized architectures, rendering them hard to program, hard to manage at runtime and have low power requirements. That is where the project ALOHA kicks in. ALOHA is a research project, funded by the EU platform Horizon 2020. It stands for Software Framework for Runtime Adaptive and Secure Deep Learning on Heterogeneous Architectures. The project proposes a toolchain that automatically generates and trains deep learning models that are optimized according to predefined constraints for security, accuracy and power performance for a specific embedded hardware platform. The toolchain can then generate optimized source code for the specified hardware. The toolflow contains a graphical user interface, where the user can define the domain and task by means of a dataset, enter the constraints and a target hardware platform description. The operation is done in 3 steps. The first step aims at automating the algorithm design process. It generates the optimal algorithm configuration taking into account the target task, the set of constraints and the target architecture that will execute the inference task. This is done by a decision-taking tool, called DSE engine. The second step of the toolflow aims at automating the system-level design process, optimizing the partitioning and the mapping of the algorithm configuration selected by the DSE in the previous phase on the target processing platform. Finally, the third step automates the porting of the target inference application on the target architecture, translating mapping information in adequate calls to computing and communication primitives exposed by the architecture. With this approach, ALOHA proposes an automation of the design process, which makes deep learning solutions available for engineers without specific artificial intelligence specialization. Besides, it bridges the gap between the proposed solutions and the specific target hardware platform, making the deployment an easier process, ensuring at the same time the utilization of the full available hardware capabilities. In the surveillance use case, we are interested in reliable algorithms for intrusion detection in critical infrastructure. For that, we want to have smart cameras capable of detecting the presence of people in high security areas. In this case, we give as input to the toolflow our dataset, our constraints and the target hardware description. The toolflow processes all the information, generates a suitable model and inference source code, which can be integrated into your application and deployed to your target platform. Please, follow us on the social media and find out how to get involved in ALOHA on our website.